Hello and welcome. Today in this video, we'll solve one more example based on a Z transform. Before that, I request you check the previous video so that you can understand the definition of Z transform and its ROC concept. Let's start. This is the question. Find the Z transform of a sequence x of n is equal to 1, 2, 3, 4. If you check the previous example, there is a difference for this n is equal to 0 position. In the previous example, n is equal to 0 is here. Now here arrow is mentioned at this position means at n is equal to 0, amplitude is 4 and this is n is equal to -1, -2 and -3. Let's see. This is our sequence 1, 2, 3, 4 and the arrow indicates at this position where n is equal to 0 starts. So our sequence is n is equal to 0, amplitude is 4. Then n is equal to -1. At the left side means -1, -2, -3. At the right side means it is 1, 2, 3. So it is at the left side. So n is equal to -1, amplitude is 3. N is equal to -2, amplitude is 2. And n is equal to -3, amplitude is 1. Now let's start to find the Z transform. We know the definition of Z transform is n varies from -infinity to infinity, x of n, z raised to -n. Now our x of n exists only for the duration -3 to 0. So there is no need of other n values as x of n is 0 for other values of n. It exists only for n is equal to -3 to 0. So limits of the n is -infinity or -3 to 0. X of n z raised to -n. Let's now put the values of n, that is -3, -2, -1 to 0. N is equal to -3. So this minus minus become plus. So z raised to 3. Then n is equal to -2. X of -2, z raised to -2. That means +2. N is equal to -1. X of -1, z raised to -1. That means +1. X of 0, z raised to 0. This we can write when we'll put the values of x of -3 is 1, x of -2 is 2, x of -1 is 3 and x of 0 is 4. And this is our x of z. Now we need to check the ROC of x of z. For which value of x of z this x of z exists? This x of z is finite. If you check this x of z, if I put z is equal to infinity, you can say that x of z is infinity. For other values of z, for any value of z, you will get some finite value. But only for z is equal to infinity here, x of z is infinite. That means, what is the ROC of x of z? ROC is the entire z plane. All the values of z except z is equal to infinity. Because for all the value of z, x of z is finite. Only z is equal to infinity, this x of z becomes finite. That's why ROC is entire z plane except z is equal to infinity. Now how to show it graphically? This is our z plane, entire z plane. Real axis, imaginary axis. And except z is equal to infinite means we can show it by bounded box to indicate except z is equal to infinity. Based on that, the second property of ROC is if x of n is finite duration, left-sided sequence, then the ROC is entire z plane except z is equal to 0. Now let's understand what is this finite duration. Check your x of n. It has finite duration means it has some 4 samples only. Not exist from -infinity or up to infinity. It has only 4 samples. So it is finite duration. Left-sided, you can check from n is equal to 0, it exists at left side. In the previous example, your sequence is right-sided. It exists for n is equal to 1, 2, 3. But here it exists for n is equal to -1, -2, -3, that is towards the left. So x of n is finite duration, only 4 samples here, that's why finite duration. Left sided at is exists for n is equal to 0 to -1 -2, that's why left sided. Then the ROC is entire z plane except z is equal to infinite. For any x of n which has a finite duration and left sided, the ROC is entire z plane except z is equal to infinite. Thank you.